Okay, I got this radio ready to go. We're gonna try it out. I got it on AM, and this on-off switch needs to be cleaned or adjusted or something, or repaired. It's not working. The button won't stay in. Somebody who worked on it before put tape on here and bared the wires, so apparently they tried to service it. It looks like they cut the wires and then twisted them together. So they probably took this off and tried to service it and didn't get anywhere, or didn't. Anyway, they didn't get it working, so they've been using, obviously using that to clip the wires together to turn the power on. So we're going to bring it up slowly. I brought it up once already, so I know that the current's fine. So I don't need my current limiting bulb. And we'll bring the voltage up. Okay, so right now we're at 43 volts and we're drawing 160 milliamps. Of course it won't play there, so we'll bring the voltage up to an area where it will play. Okay, so we're around 94 volts, drawing 0.2 amps, which is 19 watts. Of course that's not enough to get it to play. It's trying to. So we'll bring it up a little more. All right, that ought to kick it off. These controls need to be cleaned, obviously. So let me put the antenna on. Okay, that's my local station. Tone's working, but you hear how terrible it sounds. And the volume control definitely needs to be cleaned, probably even replaced, but we'll try to clean it. And on FM, I believe that's FM. Not getting nothing out of the antenna. No, not getting nothing on FM. And I'm assuming I'm on the right wire. This one should be the ground. Yeah. It comes out of this jack in the back here. So that white wire should be the antenna. But we're not getting out on FM. I don't like the sound of that. That's overdriving that transformer. Okay, and sideband, or shortwave rather. Sorry. Nothing. Okay, so I'm going to shut it off. It is drawing at 108. It's drawing 57 watts, which is fine. Probably rated at 75. So anyway, we're making progress. All we did was put in the blown out 6v6. We replaced it with that one. You know, this metal can was definitely shot. It was 0. It wasn't even registering, so it's got an open filament. And that one tests good. So we're fine there. I got to change the pilot lights. That definitely needs to be done to protect the rectifier tube. And it's a little warm. It is the original rectifier tube, but it seems to be working. At this point, the issue is most likely the capacitors. A bunch of them probably shorted out or open, most likely shorted out and letting DC go through. And it'll need an IF tuning, an RF IF tuning. But, and then I'll need to service that switch if possible, or figure out how to get around that. I think we can probably get it going if we clean it. The potentiometers controls need to be cleaned, and the buttons need to be adjusted to, well, I can't really adjust them to any particular station because I only have one station here, but they can be adjusted. I think you just pull them out. Yeah, no? Or maybe you push them in and hold them in, or they have tuning controls here in the back. I'll try to show you. There. So those tuning controls, you actually use a screwdriver and set each one for the frequency you want. That's not a big deal, but we do want to get, and you can do that from the back of the radio, obviously, right? You can push a button in and then tune the first one to where you want it. Push the next button in, and from the back of the radio, tune the next one you want, because the back's open. But we got to get it working. So the next thing is change the capacitors, change these dial lights, and check the voltages on the tubes. Check the voltage at the high voltage and see what is rectifying is putting out as B+. But I'm pretty sure 90% of the problem is the capacitors. So we're going to start with those and these lights, and we'll check resistors and as we go along. So anyway, let me get it set up and we'll work on that. Okay, I wanted to show this because this is a common mistake that people make, and now I understand why we have a 47k ohm resistor here, and it's a big one because that's probably all they had in their tool bin. But let me get a pointer here that's not conductive. This may still have some charge on these caps, and I don't want to mess with them. Okay, we have, up here we have our IF cans down this side. There's 3 of them. This is transformer 1 and 2 go through here to the top of the circuit board. So that's T1 and T2. This is T3 and T4. Okay, T3 and T4 right here go through the board. This here is T5 and T6. So T5, T6, T3 and T4. T1 and T2 is right next to it right there. So there's 2 openings, T1, T2, T3, T4, and I'm not sure if it's 4 and 3 or 3 and 4, but you get the idea. 3 and 4, 5 and 6, okay? 5 here, 6 here. This capacitor connects to, I'm sorry, it's 5 and 6 this way. This is, I'm not sure what that is. That's not it. It's this one here. This one back here and this one here. This red wire comes out and connects to this resistor, right? 47K. Now let me show you what they did. This is the schematic diagram. This is a partial of the schematic diagram with the first band set, band A. And now I understand probably why the FM wasn't working. And these are the buttons, by the way. Let me zoom in a little bit here and you'll be able to see this much better. Okay, so these are the button frequency ranges. There's 5 buttons. 1, 2, 3, 4, 5. The first button will tune from 540 to 1000, so the low end of the AM band. The second button will tune from, it looks like 600 to 1200. The third button, 650 to 1300. So you see they overlap a little. And that's so that if you got 3 stations below 1200 or below 1300, you can tune all 3 of them. The next one is 850 to 1500, and then 900 to 1600 kilocycles, or what we would call kilohertz. So this is the AM band, and you have 5 buttons, and they start from the low end of the band to the high end of the band. When the band select switch is in the first position, which is AM, these buttons are active. They can be used, and they cover these 5 ranges. Okay, so this is the standard broadcast band. Standard broadcast is AM. Okay, in the AM band, if you look at the schematic, they show T1 and T2. see? Now, if someone hasn't paid attention, they would look at this and they would say, oh, there's a 4700 ohm R9 and oh, 0.01 C10. So they see 4700. What they put in there could be 4700. That's probably a red band. Yeah, I guess that's red. It looks orange to me. It looks like they put in a 47K. It looks orange or brown more than red, but it probably got hot. So it's definitely all pitted, right? If you can see it, it's all kind of pitted all the way along its length. See that? So a discoloration has occurred. So that could be 4700 or 4.7K, which is what this is, 4.7K. And it's on this transformer. Well, the problem is this is T1 and T2. T1 and T2 are up here, and the 47K is in the switch area here. It's still intact. This one that burnt off goes to the middle can, not the top can. So there's the top can. That's T1 and T2. This is T3, T4, T5, and T6. Actually, it goes to T5 because it comes down here and it connects to this red wire here. So the resistor is connecting to the red wire and it goes in right there to T5 or 6. Actually, I can tell you which one it is. If I go back to the regular schematic, here, it goes into T5. And see, it's the red wire, and it's a 1000 ohm. So we got to replace that back to a 1000 ohm. The 4700 ohm is in here. It's R9, which is right there, R9, which is showing you that it's underneath the selector, the band selector switch. That's this guy here. That's the band selector switch. R9 is in there, not down here. So when this resistor burnt out, they didn't notice that, or they didn't have that part of the schematic. Maybe all they had was this part of the schematic. Maybe that's all they could find. I kind of doubt that, because if I can find the whole schematic in 2021, I'm sure closer to when this radio was made, the schematic was everywhere. So, but that's why they messed it up. Now it's a 0.01 here, and over here it's a 0.05. So that should have been an indication to them that this was, I see, it looks like they replaced it with a 0.0, oh no, here it is, 0.05, see? It is a 0.05, but it goes to a 1000, and that's what we were looking at the other day. It doesn't go, it does connect there, right? Yeah, it connects there. And it connects there kind of crazily. So they probably, if you notice, it's been cut off and then reconnected. They probably tried to put a 0.01 here and a 4.7 here and had bad results. So they changed this to a 0.05 and they put maybe they moved the 4.7 to a, I don't know if that's a 470. That sure looks like a 470 to me. So it should be a 1K. But anyway, that's the only thing I can see is that they were mixing this one up with that one up there, which is 4700. So that's probably a red band. It looks brown, but there's discoloration, so it's probably a red band, but I really can't tell until I disconnect it and measure it. So I'm going to do that, but I'm going to change that first with a 1000 ohm half-watt resistor, and then we'll monitor it when we go. And then I'm going to start down here changing these capacitors and work my way up to this delicate area here. Here you got to be really careful. If you move anything in here, you could throw off especially those coils there, those two coil inductors. You don't want to collapse them or stretch them out. You don't want to move wires. You notice every wire is really short. That's by design, because you don't want no antennas in here. So I got to change this one, and this one in this area, and that's a very difficult area to be in, but I'll get them done. These are not as critical. These are more just general use capacitors that are not in the very sensitive tuning area. So I'm going to start down here and work my way up. But I wanted to show you that, and show you that what I'm thinking they did is they looked at the schematic, seen the center. You know, this is the center coil here, T3 and 4, and it's right in the center of the radio, up and down, right? And so it's also in the center of this partial schematic, and I think that threw them off. See, this is about the center of the, let me go back down. And it's pretty close to the center of that schematic, right? So that might have been what threw them off, and they seen the 4700. I'm guessing, I don't know. But either way, we're going to put it back to what the schematic says, because that is what matters. So that's going. Anyway, let me change these recaps, and then we'll take another look at it, check some voltages, and make sure everything's okay, and we should be good to go. This Philco unit has to be rebuilt, but I'll do that last. Once we get everything else done, then we'll take a look at that. It'll need to be redone. I might go ahead and take it out and disconnect it temporarily and just put a couple capacitors with alligator clips to do our check while we're rebuilding that Philco block, capacitor block. All right, let me go ahead and get going. Thanks for watching. We're placing this floppy resistor that was sticking out here, flopping all over the place. It's not even the right one. It's 100 K, and it's supposed to be 180 K. And it went from this one to here, but this one's got so many wires on it, and these three are connected together, these three here. So I just connected it there to there. I'm going to connect it there. I'm going to take this off first. This was from the capacitor, big old boy. I'm going to find it. There it is. This guy here was twisted around, it was just glued on that wire there, and it went over to here, went over to there, and glued there. But I'm going to take it off, because I'm going to put this new one on with some shrink wrap, and it's going to go, I think it'll make the whole distance without a problem. Okay, but while I got this off, let's take a look at it. It's a 0.5 microfarad capacitor, right? And ground is on this side here. So if I connect it up and put this on capacitance, yeah, connect the other side up. It's reading 1.9 meg, or almost 2 meg, and of course it's leaking DC, so it's going all over the place. But 1.9 meg. It's supposed to be 0.5. It's 4 times its rated value. That's why they got to be changed. Not only is it way out of tolerance, 4 times its value, but it's also leaking DC. But before I solder that in, I'm going to go ahead and get these two that are underneath it, because they're going to be a problem. I'll get those done, and then I can run this one across them. And I also am putting that back where it belongs. That's just an audio jack. I'll have to, since they broke it off, you can inject an audio signal there right into the audio amp to check the audio amp. That's basically all that's for. It'd also be good for hooking up Bluetooth or something like that. You could actually run it through there. So what I'm going to do, this was wrapped around it, pulling it down. It was way down, he couldn't reach. They broke it off. I'm going to have to epoxy it back in place, and then I'll put an extension on this capacitor, or change the capacitor one of the other. Probably just extend it because it's fine going to it, and fix that. So that's where I'm at. I just wanted to show you this issue here with this bad resistor. A lot of the things they changed, they really messed up. I don't even know what they were doing here, why they cut that capacitor lead and then soldered it back. But they did that in a lot of places. Even the big one we just looked at was cut and then soldered back. I don't get it. I guess they cut it to see if it was leaking DC maybe. I don't know. So anyway, that's where I'm at. Thanks for watching. Okay, here's a fun one for you. This is a 5 microfarad 50 volt capacitor. It's an electrolytic. I didn't even notice it earlier. But let's take a look at this a little closer. In my hand, there you go. So it's 1 3/4 long. Right there's 1 3/4, and it's 1. Okay, from 1. Yeah, it's about 5/8 inches in diameter and almost 2 inches long. This is the replacement to give you a contrast. Now I take that back. This is 5/8 of an inch long. Actually, no, it's a 1/2 inch. It's hard to get that little ruler on there, right? It's a 1/2 inch by 3/16. So if I hold it up there you go. That's the replacement for that big capacitor. There you go. 4.7 at 50 volts. That's the replacement for that electrolytic. That's how much things have changed since this radio was made. And this radio is not really that old. This is probably a 1950s, maybe 1940s, probably 1940s. So unreal. But anyway, of course, the leads will never reach across that whole thing, right? So I got to put it in there and then mount it somehow and run a wire up to the other side, to the positive side there. I'll just ground this side here and then run a wire up from the positive. Actually, I'd rather put the positive there and run the ground down so we have a shorter, oh, wait a second. Actually, this one's going back up. Oh, it connects here. Oh, great. We can go right across. So that's the next one to go in. I got those 3 in. And then I'm going to do these so I can connect this back up. And this resistor that goes down here. I'm going to connect it back up. And then I can switch over to doing these now. Then I take that block out all at the same time. So anyway, just thought that was interesting when I seen how small that was. I'm looking through my capacitors and expecting it to be around this side, you know, and this is 250 volts. And so for 50 volts, which is clearly marked 50 volts, working voltage 56, 5 microfarads. 4.7 is the standard today. But anyway, that's what I'm going to do. Put that in and then change this one and then switch over to these and then work back up here and continue up. Thanks for watching. Well, the radio is all capped. And I put the caps laying in pretty much the same orientation as on the schematic so that if anyone had to work on it again, they could just follow the, not the schematic, the parts layout. This here, which shows where the parts are. I got them pretty much laying the exact same way. I got one a little bit different, I think, this one. But other than that, they're all pretty much the same. A lot of them were cut out and put back in, and they were put in backwards with the foil side toward the hot side of the circuit and things like that. I still got to do this guy. Also, a couple other things. I cleaned the tuning condenser, capacitor, but you'll notice that this control here is bent a little. It's not straight. I don't know. I'm gonna try to straighten that out. The others are fine. You know, I got a little cleaning to do in the chassis, and I got to change the cord. You see, it's busted there. I've moved it out of my way, and it just shattered, cracked and shattered. So the cord is brittle. It's like a rock. If you unbend it, the insulation breaks. I'll probably still try to power it up just so we can see what we got, but I'll have to replace this cord. Of course, this cord is no good, right? That's not a radio cord. It's not cloth, and it's not original to the radio. So we'll deal with that. I'm about to stand it up now and see if we can, how it does, and then from there we'll go ahead and I'll put it back up like it is now and take this. Actually, I probably should just go ahead and do that. That needs to be done anyway. So I'll probably go ahead and do this first, and then and clean it, and then I won't have to get back underneath. Well, I still will. I got to tune it. Anyway, it's recapped, ready for a test run. So thanks for watching. Well, I figured I would show again these capacitors and block capacitors and how to get this stuff out of here. Pretty much you got to dig it out. There's no other way. But if you heat it up, it's a lot better. You see it's kind of shiny there where I've been heating it up. This camera doesn't like this yellow paper, but you heat it up and it'll melt, and then it makes it easier to get it out. You don't want to pry on the side of the plastic too much because it will snap, and then you have to glue it back together. And if you just heat the inside up, you can take a screwdriver and slowly, I don't know if I can do this with one hand. I can't even seem to put the heat down. Anyway, you just kind of get in here and just pry it out like that. And there's two coils, one on this side here and one on this side here. Those are the capacitors. Okay, I'm getting close to them. Let me dig a little more and then I'll show you. Let me pause this a sec. Okay, so you can see the two capacitors in there running side by side. And you just got to dig all this out, clean it out. You get all this out. You might want to wear a mask when you do this because it's tar based, it's petroleum based. It's like a tar. And it has a lot of fumes. I don't know what's in it. There's other stuff besides just tar. So, you know, take the necessary precaution. You do this, you're doing it on your own advice. But that's how you get them out. And then you just unsolder the wires. They come through. You see the wire coming through. This hole here connects to that center pin. The other two, one comes through here and connects there, one connects there. And they're the same value, usually like 0.01 microfarad. So you can put the new caps right in the case, right? And then it gets screwed back on like that, back onto the radio, and no one ever knows that it's been changed, and it's still got the original Philco information written on it, right? It's pretty cool. Anyway, that's what I'm doing. I'm going to redo this one and then install it in the radio. Well, there it is. That's the case. If it's cleaned out, I still haven't gotten the wires out yet. You see them there? And those big lobs on the end of the wires there, those big flat things. That's the end of the capacitors here. There's one of them. So I just connected to the end through there. You see where I hit this one a little bit, digging it out. There's the other one. So they were just in there side by side like that. And if I maybe I can get this one started. I don't know. Yeah, there we go. There's the capacitor. Now you see what's in a capacitor in these old ones. And you also see why they got to be replaced. See that damage there in the middle here? That's where the acid in the paper ate right through the aluminum foil. The aluminum foil deteriorated with age, so this one is probably shorted out. And you see they're just basically, if I undo this, it's a little hard to do and hold the camera, but basically it's two pieces of aluminum foil here with paper between them. So there's the paper, there's one aluminum foil. You can see the edge of the paper here. And there's the other aluminum foil there. So it's just those two aluminum foils wrapped with paper, and this paper on both sides so that when you roll it up. But you see where the damage is? Look what it did to that aluminum foil. You see that? And that's inside, so I didn't do that. That's inside. You see the paper doesn't have any holes in it. This one was about to go open pretty soon. It already opened all the way up to there. As soon as that little area there let go, this would be open. In the meantime, it's probably shorted. But that's why you got to replace them. And, you know, it keeps rolling. It's just two of them rolled together. And you see, it's hard for me. You can get it closer to the light. And you see, it just keeps rolling. It's just two foils with wax paper on both sides. And there's the end cap. On the inside one, at the very inside edge, one of the aluminum foils connects to a lead. And on the very outside edge, the other one connects to a lead. So it's like two long plates, right? With an isolation between them. That's what a capacitor is. That's why on a schematic, when you're looking at a capacitor on a schematic, it always shows them as two lines, because that's what they really are. But now the two lines are really long. They go like from way over here to way over there, and then way over there, and way back with paper in between. And of course, they're not going to make capacitors that are 2 feet long and try to stick them in the radio, so you roll them up. And they roll them up like a donut, like a Swiss roll or some kind of roll. Little Debbie Swiss rolls. That's what they remind me of. And they roll them up, and one lead connects on inside, and the other lead connects on the outside. And that's why they have on the outside. That's why capacitors have to be with the negative side facing the negative end of the circuit, because the negative side is not just the lead, but it's also the outside of the roll, this outer edge of the roll. And so that's like a big antenna, right? That's just a big old aluminum antenna picking up all kinds of noise. So you definitely want all the noise that it picks up going right to the ground side, and sucked off basically, so it doesn't get in and amplified in the circuit. So, but a lot of people just flip these in any way they want. And you don't want to do that. You got to get an oscilloscope and find out how they go. Notice old capacitors like this that I took out of here, they got that black band. But they also say on this one, it says outside. Can you see that there? Outside foil. It says right above it, outside foil. That'll let you know that this is the outside of the roll, and this ground lead connects to the outside of the roll. So any signal that hits this, RF signal that hits this, goes right through the ground lead and right to ground, and it's grounded out, which shields the hot end, which is amplifies, is the side that's amplified. So the only length is this wire here, and it's just a little thin wire, as opposed to all the surface area of that outside foil plus this wire. So that's why you got to put them in the right way, okay? People are not just being picky when they say that. There's reason, and the reason is because you don't want this whole thing, if you put it in backwards, this whole thing becomes an antenna. All this surface area becomes an antenna, picking up all kinds of RF and noise. No, you don't want that. You want it to pick up all the RF and noise, but you want this to the ground side of the circuit, so it just sends it to ground and grounds it out. And so the part that connects to the amplifier part of the circuit, whether it's IF or audio, doesn't have much or surface area. It's just a little fine wire. The other thing is when you put these in, and most of these in the right circuit are that way, you'll notice that they have much longer. Now I cut this one out, but you get the idea. It's much longer on the ground side because you want to pick up all the noise around it and send it to ground, including from the foil. And on the positive end, you want to keep that as short as possible. So I had to wedge in to cut this one out because it was short, because you don't want this acting like an antenna. This, you do. You want this to suck all the signal, all the noise, and throw it to ground so that it doesn't get amplified from the positive side. Well, now you know what's in the capacitor. You get to see it. And that's what's in these. That's what's in all of these. That's what's in here. It's what's in every one of them, even these electrolytics, this dry electrolytic. So, anyway, now what I'm going to do is unsolder those leads, pull them out, and put the new capacitors in and feed the leads through. And they'll be side by side just like they were, but I ain't going to fill it with tar. Don't need it. They're poly-coated, right? The new ones, they're solid. They're not going to unravel like this. They're not going to corrode like this. They'll last longer than the originals, and because they're sealed, right? Moisture can't get in there, so they can't deteriorate. And the paper that they use, they learned about paper acid, just like in art, right? How did they find out in art that you had to use acid-free paper? Well, the artwork started deteriorating, and then they found out it was acid in the paper that was deteriorating the artwork. Well, in here it's doing the exact same thing to the foil. So now that when they make them with Well, they use, I believe they use poly as a separator. I don't even think they use paper in these at all. I'm not sure. I've never taken one apart to see what's in it, but I have a feeling that it's just a plastic insulator. And I'll be back. Well, I got the radio recapped and powered up. And that's on AM. On 105 volts. Drawing 49 watts. 0.5 amps. Got my current limiting off because I checked the voltages. They seem fine in the tubes. That's, what a sound. And of course that's got treble. I can't leave it there, unfortunately, because of copyright. But it has treble and bass. And we're going to try a different band. If I can get it to turn. It's hard to turn. Okay, this should be FM. Of course, I don't have an FM antenna. Let's see if I can get that out of there without getting electrocuted. Okay. Okay, that's not the FM antenna. So I must be still on AM. Let's try flipping the band again. Let's try that band. That don't seem to be FM. Seems like it only wants to work with that antenna wire, which is this one here. Okay, that might be shortwave, because that sounds like a digital clock.
Award and those achieving distance. Deadline is October 5th.
Okay, I don't know.
More great relaxing all-time the new 1077 The Breeze.
Okay, the only thing it's pulling in is my local station. And that would be push buttons. Okay, so that's push buttons. This would be AM. Push buttons, AM, FM, which is definitely quiet and probably shortwave. So this is probably FM here. That's probably the FM. It definitely needs an IF tune, right? I mean, I haven't tuned it. Yeah, I think it just needs to be tuned. I'll have to set it up to do an IF tune, which I will do tomorrow, because it's kind of late right now. But it's working, and that's with just 105 volts going in. So, I can power it down, let it cool off. But yeah, once I get it set up, I'll inject a signal in it, and we'll try a couple signals, like some AM channels and some FM frequencies, and see how it's doing, and then we'll work on tuning it. So, not bad for just recapping. We're getting there. Changed the electrolytics, and I started to get some sound. I changed the caps, and it's tuning. So that's a good sign. Anyway, thanks for watching. I'll upload more parts as I go along. Thank you.